Assalamualaikum and hi, I am Wondershare Filmora from Industrial Physics Sem4. So here I will present the video assignment of Physics 644, which is Basic Semiconductor Fabrication Lab. The topic that I choose for this assignment is oxide growth. For this topic, I will review about wafer cleaning process, dry and wet oxidation, thickness measurement and oxide growth rate. First, for wafer cleaning process, I will discuss about wafer wet cleaning. Wafer need to be cleaned to remove the dust and stains that will cause defects in semiconductor wafer manufacturing process. Firstly, the wafer will be immersed in BOE for 60 seconds. Then it will be rinsed under the flowing deionized water. If it is hydrophilic, it will be repeated 1 to 3 times until it is hydrophobic. Then it will be dried with the dryer. The thickness will be measured and its thickness will be about 300 to 400 Armstrong. Next, for dry oxidation, firstly, the wafer will be put in the furnace. The switches will be turned on. The nitrogen gas valve will be opened at 11 SLM and set the temperature to 200 degrees Celsius. The temperature will be gradually increased until 1000 degrees Celsius with the increment of 200 degrees Celsius each time. After it reaches 1000 degrees Celsius, wait 10 minutes for the system to reach equilibrium. Next, close the nitrogen gas valve. Then open the oxygen gas valve at 12 SLM and wait for 60 minutes. Close the oxygen gas valve. Next, open the nitrogen gas valve at 11 SLM and set the temperature master control at 27 degrees Celsius and wait for 5 minutes. Close the nitrogen gas valve and wait until the temperature reaches 27 degrees Celsius. Turn off the furnace switches and take out the wafer. The thickness will be measured and it will be about 800 to 1000 degrees Celsius. Oxide thickness and the oxide growth rate will be calculated. Now, for wet oxidation, first, place the wafer in the furnace and turn on the switches. Open the nitrogen gas valve at 11 SLM and set the temperature master control at 200 degrees Celsius. The temperature will be gradually increased until 600 degrees Celsius with the increment of 200 degrees Celsius each time and wait for 10 minutes after it reaches the set point. Then turn on the water bubbler heater. Next, set the temperature master control at 800 degrees Celsius and increase the temperature gradually until 1000 degrees Celsius with the increment of 200 degrees Celsius each time. After it reaches the set point, wait 10 minutes for the system to reach the equilibrium state. Close the nitrogen gas valve. Then we need to ensure that the water has boiled and the water vapor is produced. Next, open the oxygen gas valve at 12 SLM and open the water bubbler valve. Let the oxygen flow through the water bubbler. By close the valve that let the oxygen gas flow directly to the furnace. Wait for 60 minutes and turn off the water bubbler switches. Close the oxygen gas valve. Then open the nitrogen gas valve at 11 SLM and set the temperature master control at 27 degrees Celsius and wait for 5 minutes. Next, close the nitrogen gas valve and wait until the temperature reaches 27 degrees Celsius. Then turn off the furnace switches and take out the wafer. Measure the thickness and it will be about 4000 to 5000 Armstrong. The oxidation thickness and oxide growth rate will be measured. Then, the thickness measurement. For this section, the thickness of the wafer will be measured by the film matrix. The picture shows the film matrix that will be used in our lab. Then, the oxide thickness can be measured by subtract the final thickness of the wafer, which is after the oxidation, with the initial thickness. Lastly, for the last section, which is the oxide growth rate. The oxide growth rate can be measured by divided the oxide thickness with the 3600 seconds. From this topic, we can see that the wet oxidation has a high oxide growth rate than dry oxidation, but it has low quality. The equation for the wet oxidation is silicon plus 2H2O and get the silicon dioxide, solid silicon dioxide, and 2H2 hydrogen gas. While for dry oxidation, silicon plus oxygen and we will get solid silicon dioxide. So if we want to get the high quality for the wafer, we can use dry oxidation. I think that is all for the topic of oxide growth from me. Thank you.